Members, today we are going to see applications of differentiations, and these can be used in such examples. Now, the number I have here is a man wishes to fence a rectangular farm of area that with one side already covered with an existing wall. If he wants to minimize the costs, find the least possible length of the wire mesh. Wire mesh is what we use to cover. He has to use. Now, the hint we are using here is for always the maximum or minimum values. If they don't say maximum, they can say greatest stroke least. So minimum can be least or maximum can be greatest value is always our first derivative is always equal to 0. Now, I'm assuming that now this is the farm this man wants to make. But they are telling us that one side, you can choose any side. You can choose this side or this side. But one side of the farm is already covered with the existing wall. Meaning, this man had a farm, but one of the sides there is already a wall. Assuming now this is the wall, now I'm going to fence this, then this. So, one side is already having the wall. Now, they want us to find the length of the wire mesh is going to use now to cover the remaining sides, which are these 3. Now see that always this is called our length, and this is called our width, and this is our width. Also, even if you will say that the existing side is the width, it's okay. The answers will be the same. So now we start now to get the length. Of course, I'm dealing with the perimeter of this farm. So now start my perimeter will be, I will add W plus L plus W. I will add these 2 sides. I mean 3 sides, which will be 2W plus L, because I call this equation 1, because I need the length of the whole of these remaining 3 sides. But they gave me the area, but I know that my area is always equal to length times width. But now my area this time round, so my area times width will be, now the area given to me was 1,250 meters squared. Now from here, we need to make one the subject. And then make the subject. So if I make W the subject, so my W now will be 120 over L. If I make the subject, and I call this equation 2. Now, I want to substitute now this equation 2. So we have now my perimeter equal to 2 into now. W is this 1,000 L then plus L. So if I multiply this, you start my perimeter will be 2,500. Then when I take this L up, I get now this, then plus L. Now to know I want the least possible. So it means that now I'm going to differentiate this with respect to the length. So to get the least possible length. So now my dp, the L will be, and I know what this will be now, negative 2,500. Now reduce the power by 1 to 2. When I differentiate this, I get 1. So now you see that when I push this down, always for the least possible length, always our dp, the L should be equal to 0. So this will be now 0 equal to, now this will be negative 2,500. When I push now this down to be now L squared, then plus 1. Multiplying through by L squared, BRB 0 equal to negative 2,500, then plus L squared. So that my L squared will be 2,500. When I take this side, now to get the square root, you see that now the square root of this will be the square root of that we just said. Calculate the square root of, and so that this will be 50. Now these are in meters. Now if my length is this, now I need to come and get my width. The width by my width from here, so that my width is equal to 1,250 over the length. By my length is now L. Okay. which will be 1250 over the length is 50. And the C5 just right there. Now your width will be my width will be, I think when we multiply this will get 25. Now this will be 25 meters. Now from here, remember my perimeter is this, so my perimeter we say is 2L plus, 2W plus L, which will be 2 into 25 plus L, which is 50, and the answer we get here is 100 meters. So the wireless this man can use to minimize the costs is of length 100 meters. I wish you the best. Don't forget to subscribe to this channel.